Hi, my name is Spoons. I'm the CTO and a co-founder at Lightstep. I've spent years working with developers and SRE to improve reliability and productivity, and I'm excited to be here today to talk about service ownership. I'll talk about what it is and the benefits and how we can drive toward it using distributed tracing. To start off, I just want to make sure we understand what service ownership is. Really, it's about taking the responsibilities of the entire engineering organization, that is, building software and delivering service, and pushing those down to the individual application developer teams. That means that these teams are not just responsible for writing code and fixing bugs, but for things like incident response, cost management, and even capacity planning. Now, by pushing that responsibility down, we give those folks a chance to make more decisions about how they work, and that can lead to more independence and higher developer velocity. It also means we can set clear and measurable goals for those teams and hold them accountable to those goals. Of course, there's some challenges that come with service ownership, and I'll set a little context for that next. In any software system, and really this goes for a lot of other software systems too, we have a feedback loop. And on one side of that feedback loop, we've got the systems, the tools, and the processes that we use to control our production systems. Now, in modern software development, this is things like Kubernetes and associated tools. It might be configuration management systems. It might even be things like a service mesh. On the other side, we've got the systems, the tools, and the processes that we use to observe what's happening in our applications. Now, we've recently started calling these observability tools, but we've had tools like this for a long time. Now, the thing that I think has happened is that we've had a lot of innovation and a lot of times a lot of investment on the top half of this, but a lot less investment in the tools that help us understand what's happening and matching up causes and effects. And that's a bit of a problem, I think, because it's like we've built a really fast car with no speedometer. So we can accelerate really quickly, but we have no idea how fast we're going. And unlike the tools that we use to control production systems, where we can focus on the work and the actions of individual teams, the way that we observe and the tools that we use to do that need to take a holistic perspective on the application. And this is where distributed tracing is really critical. By taking a request-centric point of view, it'll show you how each service is handling part of a user's request. I'll talk a bit more about distributed tracing in a second, but first I want to be super clear. I used the word accountability before, and accountability is certainly important, but I think it's really only half of ownership. The other half, and I think this is often forgotten, is that in addition to holding teams accountable, we also need to give them agency. That is, we need to give them the means to improve things. And a big part of that means is going to be distributed tracing. So I'm going to weave these three topics through the rest of the presentation as I go through some more specifics about service ownership. But first, let me make sure that we're all on the same page about distributed tracing. Distributed tracing tools will often show you something that looks like this, or maybe like this, or this, or this. These are all visualizations of individual traces. They look a little bit like a Gantt chart, right? Time goes from left to right, and each of the bars represents some work that's done by an individual service as part of processing a request. But these are really just the building blocks of what you can do with distributed tracing. They are the raw material, not the finished product. Really, they're just structs, right? They are just a format for data that's coming over the wire. And now if we contrast traces with distributed tracing, that is the art and science of deriving value from those traces. This is where we look at aggregates of those traces, where we try to derive additional value through additional analysis. If you want to get a sense of the kinds of analysis that you could do, you could take a look at the Dapper paper. This is a paper written by one of my co-authors and others at Google, talking about Dapper, which is Google's internal tracing system and a basis for a lot of tracing systems that have been deployed since then. And it talks about not only how it was deployed, but some of the ways that they used it and the kinds of analyses that they did. In addition, I encourage everyone to take a look at distributed tracing in practice. This is a book that I helped write. It goes through not only what distributed tracing is and how you get started, but thinking about the costs and the value that you can derive from distributed tracing as well. And the royalties are all going to charity, so I encourage everyone to go pick up a copy today. Okay, let's talk about ownership. Now, I want to be specific and talk about three specific areas where you can work within your organization to help build and maintain ownership. And I'm going to cover each of those in turn. The first one is documentation. The second one is on-call. And finally, I'll cover service level objectives. Okay, let's start with documentation. So as we thought about service ownership at Lightstep, and as I've done this in other organizations, I thought about how to divide the responsibilities. And really, my first question I asked is, where are the experts? Before we can assign owners, we got to know who has the information, who has the knowledge to actually take ownership. So writing that down is important. Writing that down in a centralized place is also really important. It allows other teams to find those experts and ask questions. And centralized documentation is actually a really easy way to find a lot of related information for a service, whether that's telemetry and dashboards, alert definitions, or the playbooks that you would use if those alerts actually fired. One piece of advice I have is to use a template for that. That's what we've done at Lightstep, and it makes it really easy to ensure that you've got some consistency across the organization in terms of what information you're recording about each service. It also lets you extract information in a programmatic way. So now you can ask questions about where the experts live in your organization and how expertise is distributed. And if you've centralized it, you can also do things like track last modified dates, and that lets you require periodic audits or updates to that documentation. Once you've centralized it, the next step is to make it machine readable. Now, if it's machine readable, like this example I have here that I took from our documentation, means that you can actually easily extract information from it and use it to generate things like dashboard configuration, escalation policies, and even the way that the deployments happen. This is great because now you've taken what is a lot of mundane work in writing this configuration and you've made it easy to extract it. Even better, you've made that documentation necessary for day-to-day work, and now developers have a really strong incentive to keep it up to date, because in fact, they might not even be able to do their day-to-day work without keeping it up to date. Finally, some documentation really needs to be dynamic. So it really even shouldn't be written by people. So if you think about the dependencies of a particular service, this was something that we spent a long time at Google trying to document, to keep track of. And ultimately, that information has to come from the software itself. It can't come from humans, because humans are never going to be able to keep up with changes that are happening in the software quickly enough. So here's an example of a diagram that's taken from Lightstep's internal services. And we're able, through the use of distributed tracing, using those traces in aggregate to extract information, understand not only the immediate dependencies, but the transitive dependencies of services as well, and understand how those services are impacting latency of our service. Okay, documentation is important. Of course, everyone thinks that documentation is important, but really I think it should be one of the first steps that you think about when you're thinking about rolling out service ownership. Documentation lets you record who's accountable. That is, it's a shared database of ownership, right? It's the place where you establish that. In addition, it'll allow you to automate a lot of new tests that can save a lot of time, and it's also really important for training new team members or even internal transfers within your organization. And finally, I think this is important. Documentation is really important for building confidence. You know, developers want to do a good job, most of them, probably all the ones in your organization, but if they don't feel like they have the information required to do a good job, they're going to not feel very confident. They're not going to feel good about those responsibilities. So as we add new responsibilities, as we push responsibilities for service ownership down to teams, we want to make sure that those folks have the confidence to do those jobs well. There's nowhere that's more important than on-call. This is one of the most stressful moments for a lot of engineers. And if you're going to establish service ownership in your organization, on-call is a really important part of doing that well. Now, on-call, most folks think of as incident response. Obviously, that's a big part of on-call. But in organizations that I've been part of, on-call is also responsible for a lot of other stuff. So it might be communicating status internally and externally. On-call is often responsible for change management within production. That might be deploying new code or pushing infrastructure changes. On-call often does a lot of passive monitoring as well, looking at dashboards or maybe triaging low urgency alerts. And in some cases, they're also responsible for other interrupt-driven work. So that could be handling customer requests or other kinds of questions that come up. And of course, on-call needs to handle shift handoffs and make that information make sure information gets to the right people. And finally, when things do go wrong, on-call is responsible for writing postmortems. So thinking about how to make sure that on-call is done well and is the best experience that it can be, really thinking about what are the alerts that are being delivered and making sure that those are the best alerts that they can be. So we can do that by making those alerts more actionable. We can reduce the number of alerts, right? Give teams the ability to determine what are the right alerts for them to be acting on. Reduce alert fatigue, right? But even better, make sure that we're delivering alerts to the right teams, right? And I want to give an example of this that I learned about from the community. The credit for this goes to some folks at Zalando, including Luis Monero. And what they did was they actually used distributed tracing to deliver alerts to the team that they thought could best act on those. So here's how it worked. They still alerted based upon symptoms, that is based upon things that their end users were experiencing. So in this case, maybe checkout failed. But instead of immediately paging the checkout service when there's a problem, they looked at traces that had those errors in them. And they said, okay, checkout service has errors. What are the immediate dependencies of the checkout service? And do any of those immediate dependencies also have errors? If yes, repeat the process, go look at any of the dependencies of those services, again, looking for errors, until we find a service with no dependencies or no dependencies with errors. And then those are the teams that we should be paging. And they found that this was a really effective way to get the right people involved at the right time. And it's also just a way of, letting people sleep if they're not going to be able to do anything to help address a situation. Finally, I want to talk just for a minute about postmortems. Postmortems are also, I think, a really critical part of on-call. They're really about how do we do better next time? How do we improve things? In part, that's making sure that we've fixed root causes, that we actually make sure that we addressed what happened. But it's also about making sure that our responses will be better next time, even if the issues themselves are novel. Now, of course, postmortems need to be blameless, that we want to make sure that we are getting all the information and that we understand that it's about improving the process and not about pointing fingers. But to do that, it's really important to establish what happened in an objective way. And in our experience at Google, it was really important to use distributed tracing as part of that. I think it's easy for teams looking at their own metrics to say that it wasn't their services at fault. It wasn't their software that was to blame. But ultimately, what a trace does is it allows you to connect different services within individual requests and understand how each of those services is participating and how they view latency within that request or how they view errors within those requests. So again, tracing really helps establish what happened, and that's really important as part of a postmortem. Okay, on-call, obviously important. It has direct impact on customer experience. It can have impact on revenue, reputation, and things like that. It's also, there's other costs involved in on-call, right? So if you've now made on-call responsibility of every one of your application developer teams, the time that they spend handling pages, writing postmortems, or handling other interrupts, that's time that they're not spending building new features or doing proactive optimization. So there's a cost there as well. And then finally, on-call is a major source of stress for a lot of developers, right? And it has a big impact on their job satisfaction. And so improving on-call is a way to help them, is a way to lower that stress and help them really embrace service ownership, right? Like they will be much more eager to participate in that if we make on-call a less stressful undertaking for them. Finally, I want to talk a little bit about how we measure success in on-call, and that's through service level objectives. These are promises that service owners make to their customers, and those customers might be internal to your organization or external. And those promises are stated in a way that can be easily measured on short timescales. So that might mean days or hours or even minutes. So to take an example of an SLO, it might look something like this. You might say that 99th percentile latency should be less than 5 seconds over the last 5 minutes. And there's 3 important parts here. First, there's the service level indicator. That's the thing that you're measuring, right? Then you've got a threshold, which says what your goal for that is. In this case, you want to keep it under 5 seconds. And finally, you say explicitly what the measurement window is. And this is really critical because if you don't specify this, then there are a lot of ways of measuring it, and we might not be talking about the same thing as we're talking across the organization. Now, there's a lot of other kinds of indicators that might be important for your business. It might be something like error rate or availability, or it could even be something like durability or throughput. But in any case, the way that you determine the SLOs is going to be the same. You want to ask, what do your customers expect? What promises have you made to your customers, either implicitly or maybe in writing? And then what can you provide today? What's the current state of the software and the services that you're providing? And how do you expect that to change over time? Maybe you'll have a bunch of time to do reliability improvement, and maybe that's a reason to set a tighter bound. Or maybe you have a big feature coming up and you expect that you might not have as much time to do that. So this is how you can take what your external customers expect and translate that into SLOs. But how do you take it and figure out what the internal services should be delivering? Okay, well, let's take an example to understand how we do that. So say service A here at the top of my graph, that is an external facing service. So we use the commitment we made to our external customers to determine its SLO, and say it's that P99 latency should be less than 5 seconds, again, for some measurement window. Now we're trying to figure out, well, how does that map to what B and C need to deliver? Well, surprisingly, we're going to look at a trace to figure that out. This trace tells us the structure of the requests and how each of the different services participate. So from the trace, we can learn that B is actually responsible for a pretty big portion of the latency. And so we might want to set its SLO to be pretty similar to what A provides. Maybe we need to make it a little bit tighter, but I'm just going to assume for the sake of simplicity that it's also P99 latency less than 5 seconds. Now, when we look at C, things get a little bit more interesting because you'll note that there's 2 requests that happen for service C for each request that comes into services A and B. That means not only that the latency needs to be faster, but there's 2 opportunities for C to fail to meet that bound. So you might think initially that we just need P99 latency to be less than 2.5 seconds, just dividing that 5 seconds in half, when in fact we actually need to make it even tighter than that. Again, there's 2 opportunities for C to fail. think hard about the statistics and you'll figure it out. Finally, it might be that B depends on other services in other cases, like maybe it also depends on D in some cases, but the trace has told us that D doesn't participate in these requests from A, so A's SLO is not helpful in understanding the SLO for service D. Why are SLOs important? Well, they are the measure of success in delivering service, and so you need to measure them and need to use that in terms of holding teams accountable. But they're also a way for teams to use, they're a tool for teams to use to guide in how they prioritize their own work. So if a team has a lot of room before they meet their SLO, that might mean that they want to invest elsewhere, building new features or maybe thinking about optimization work. On the other hand, if they're very close to their SLO, maybe they should be thinking about investing in reliability. And then finally, SLOs are important in how you communicate across your organization, right? You want to communicate consistently and you want to hold teams accountable in a uniform way. And you want to do that transparently. So we want to have an opportunity for every team to see how close they are to their SLO, because these teams depend on each other. These aren't just things that they're doing for themselves. It's a way of them making their obligations to their other customers, again, internal and external, explicit. Okay, to review, so I had these 3 puzzle pieces I think are 3 important steps in building and maintaining service ownership. Documentation, although sort of apple pie in some ways, documentation is always good, but really for ownership, it is what establishes that, right? It's who you will hold accountable. And it's also really important in building the confidence of the folks on those teams to make sure that they understand how the system operates and that they have the information they need to do their jobs well. But don't try to manage all of that documentation manually. Things like dependencies really should come from the telemetry, from things like distributed traces, rather than something that's maintained manually by humans. On-call, obviously really important. Also an opportunity for developers to feel stress, but an opportunity for the organization to do a good job in relieving that stress. It's often more than just incident response. It might include other things like handling interrupts and managing change. But tracing is really pervasive and on-call, not only as part of root cause analysis, but also as parts of the kind of automation that I talked about and how pages might be delivered, and as a way of communicating about what's happening in production. Finally, SLOs, as I said, they're how you measure success, but defining objectives for internal services can be tricky if you don't have a tool like tracing to help you do that. Okay, to sum up, ownership, I think, has 2 important parts. Of course, accountability. We want to set goals and deliverables for service owners and judge their performance based upon those goals and deliverables. But just as important, we need to give them agency, right? We need to give them the means, and that could be the information, that could be the confidence, and it could be the budget to improve the quality of service that they're providing and meet those goals. And as I've talked about today, tracing provides key information to drive both of those things. Just a quick note about Lightstep. Lightstep is best-in-breed distributed tracing solution. If you're interested, you could go to go.lightstep.com/request-a-demo, and a tracing expert will contact you to give you more information. And with that, I want to thank everyone for their attention. I'm Spoons. I'm a CTO at Lightstep. You can find me on Twitter at @save_spoons or spoons@lightstep.com. Thanks.